All right, y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So on the factoring, this is a sum of two cubes, so you're going to want to use your formula. You're going to find the cube root of 343. That's going to be a 7. So you're going to have 7m plus 4n, and then 49m squared, minus 28mn, and then plus 16n squared. And so this is going to be your answer for your factoring. For the math knowledge question, it says for the first several months after the scooter arrived, the rate of sales was really slow. So it started at 0, and it's going to increase slowly. So we can go ahead and eliminate J, because it didn't start at 0. And then it increased rapidly. Well, that means that H is not going to work, because that's a constant rate of increase. The slope is the same. So we want to see where it has a slow increase, and then it jumps up, and then it levels off because the rate of sales decreased at the end. The only one that does that is K, and so that's going to be your answer here. F is a more rapid increase, and then as time goes on, it slows off. And then G is a slow increase, and then it begins to increase a little bit more rapidly, but neither one of those has a leveling off at the end like K does. Okay? So now we're going to look at lesson 80. We're dealing with trigonometric identities, part 2. We're going to be looking at some show that's today, but before we do that, we've got to get some more trig identities. So hopefully you'll understand these trig identities in relation to your show that's. So this is the Pythagorean identity. Sine squared plus cosine squared equals 1. We did talk about it last year in geometry towards the end of the year, so you may remember it from there. But this is Pythagorean's trig identity, and it is one that you will definitely want to learn. Okay? Now, this is also a Pythagorean identity, and I'm going to show you how we get from sine squared plus cosine squared equals 1 to this second one. So cotangent squared or cosecant squared, they're both if you divide by sine squared. And I'm going to divide every term by sine squared. And sine squared divided by sine squared is 1. Cosine squared over sine squared is cotangent squared. And then 1 over sine squared is cosecant squared. And so if you just divide all your terms by sine squared, you get to this other Pythagorean identity. We can also do the same thing and divide everything by cosine squared, and you'll get tangent squared plus 1 equals secant squared. And I'll show you. Divide everything by cosine squared. Sine squared over cosine squared is tangent squared. Cosine over cosine goes to 1. And then 1 over a cosine squared is just secant squared. And so that's how you can develop the other two. You definitely have to memorize sine squared plus cosine squared equals 1. The other two are good to know, but if you forget them, you can always derive them pretty quickly by taking the sine squared plus cosine squared equals 1. Okay, so that's the one that you have to know, and then the other ones are just sometimes helpful to know. Now, you can rewrite any of these three two other ways. I could say that sine squared equals 1 minus cosine squared. Or I could say cosine squared equals 1 minus sine squared. And I can do the same concept to the other two. So they're not always going to be, exactly in this format. They may make you have to add or subtract the term so that you can use them. So we've got to show that. We want to show that these two are equal. So on show that, remember, you want to pick one side to work with. And you want to pick the one that's going to make it easier for you to simplify, which 97% of the time is going to be the one on the left. And if you look here, obviously we're not going to try and simplify sine squared. We want to simplify the left side. So you start by writing the left side. So we write the left side. And now we want to somehow simplify these over here. Well, I'm going to go back. What is 1 plus cotangent squared? 1 plus cotangent squared is cosecant squared. So I can make this over cosecant squared. Now somehow I want to simplify the top. Well, what is secant squared minus tangent squared? Let's look back. The bottom one has secant and tangent. And if I make it secant squared minus tangent squared, that's going to give me just a 1. And so I'm going to have 1 over cosecant squared. And the reciprocal of cosecant is sine. So this is going to become sine squared of x, which is what we have on the right side. And so all of this would be our answer. Okay? Looking at another example, we want to show that these are equal. So we're going to work with the left side. We're going to start by writing it down. We're going to have 1 over tangent of A plus tangent of A. Now what I want to do is to multiply and make it into one fraction. And so I'll have 1 plus tangent squared A over tangent of A. Now, 1 plus tangent squared of A, let's look back and see. 1 plus tangent squared of an angle equals secant squared. So this numerator is actually just secant squared A over tangent of A. And so now I'm going to take secant squared and make it 1. I'm actually going to leave it as secant squared. I'm going to rewrite tangent. I'm going to say times cotangent. Instead of dividing by tangent, I can multiply by cotangent. And now I'm going to say secant squared A times cotangent is cosine over sine. And if you look at secant squared, I can rewrite that as 1 over cosine squared times cosine of A over sine. And so one of the cosines will cancel, and I'll have 1 over cosine A times sine A. Now if you look back up to here, that's not quite what the right side is, but what is 1 over cosine? It's secant, and what is 1 over sine? It's cosecant. So if we take the reciprocal, we would have secant of A and then cosecant of A, which is what they gave us. So all of this here would be your answer. Okay, let's look at another one. We want to show that these two are equal. So on the left side, we have two fractions, and what we're going to do is actually multiply them together, but we've got to start by writing them down. And so if we multiply, we're going to have 1 minus cosine of A plus 1 plus cosine of A. And then in our denominator, we'll have 1 plus cosine of A times 1 minus cosine of A. And so in the numerator, the cosine of A's disappear, and we just have a 2. Now in the denominator, we have 1 minus cosine of A plus cosine of A, and then minus cosine squared of A. And so those cosines cancel, and we have 2 over 1 minus cosine squared of A. Now what is 1 minus cosine squared of A? That is sine squared. And so let's look and see, is that what they gave us? No, they told us it was 2 cosecant squared. But the reciprocal of sine is cosecant. So we can just write cosecant squared of A. And so all of this would be your answer here. All right, let's look at one more. We want to show that these two are equal. So we're going to start on the left side. We're going to write it out. And then we're going to multiply so that we have one fraction. So I'm going to have cosine of A and then 1 plus sine of A. And I don't want to distribute that because I don't know what cosine of A, sine of A really does anything for me. We're just going to leave it like that for now. So I'm going to have cosine times cosine, cosine squared. And then I'm going to have 1 plus sine A times 1 plus sine of A. And so we're going to distribute. We're going to have 1 plus sine of A plus sine of A, and then plus sine squared. And then I have cosine of A and 1 plus sine of A. And so now, cosine squared A and sine squared A are a 1. And I have another 1 right here. So 1 plus 1 is 2. And then I have 2 sine A's over cosine of 1 plus sine A. At this point, I can factor out a 2 in my numerator. Whoop, I left off a little A there. Cosine of A, and then 1 plus sine of A. And the 1 plus sine of A's cancel, and I have 2 over cosine, which they didn't give me that. They gave me 2 secant, but the reciprocal of cosine is secant. So that simplifies to 2 secant of A. So all of this here would be your answer. So hopefully that makes sense on how you would apply using the Pythagorean identities for your trig functions here for your show that's. Make sure that you do 1 through 30 for your homework tonight so that we can go over any questions you have tomorrow.